Hi, everybody. I'm Jeannie Egmon. I'm the CEO and founder of Third Angle Inc., and we help companies with innovation and entrepreneurship inside their companies, especially by finding treasures and assets and connecting them together in new ways. And one of those assets that's been in my life for a long time is Adam Burns, who you'll meet here in just a second. I've known Adam his entire life. We've recently started working together on some software development around linking the more tangible financial and technical assets of companies with the more intangible ones to have holistic solutions and how to visualize and make those connect. Adam certainly knows a lot about making connections between a lot of data through his work with Amazon. He's a software development engineer at Amazon with a multidisciplinary background spanning computer science, atmospheric science, and civil, environmental, and electrical engineering. Wow, that's a lot. His work focuses on developing scalable, resilient software solutions that support complex systems at scale. With a systems driven mindset and a passion for solving high impact problems, Adam brings a unique ability to bridge the technical and strategic dimensions of modern engineering. So, with that, I introduce you to Adam Burns. Hi, Adam. Welcome.
Hi, Dr. Egmon. Thank you for having me.
I read that long list of your background, of all of your training and interest, and how have those different fields, either individually or collectively, come together to shape the way you think?
Yeah, definitely. It's a good question. And it definitely doesn't on paper seem like a linear path as far as my varied background goes. But overall, I think that there has been one underlying theme for me, which is just a belief and a curiosity about understanding complex systems. And I think that applies to pretty much all of the experiences that I've had throughout my background that really drew me in. Atmospheric science was my first true immersion into a massive, beautifully chaotic system. Through that, I learned very quickly you can't just predict the weather by looking at a cloud, right? You have to zoom out and see the big picture. You have to look closely at these minute interplay of forces across an entire continent. Really complex stuff. And I think the principle there, the need to see the big picture, is directly applicable to all other engineering focuses. But yeah, later on, my time in civil engineering was focused on sustainability and resilience, and engineers don't build a bridge hoping it's going to withstand a 100-year storm, right? Instead, they build it with the expectation that it will. And it's kind of that design for failure philosophy that is at the core of how we build like reliable software in software engineering. It's not about preventing every problem. It's about like building systems that can endure them.
So, when you say designing for failure, you mean testing it so it won't fail or designing it so it's almost failure proof?
Well, that's the thing. It's not about trying to like think about every possible way it could fail, but it's more of designing it so that if something does fail, the whole system continues to run.
Gotcha.
That
There's
adds more
complexity in it.
resilience.
Yeah, right. That's wonderful. Well, with that, then it must involve a lot of pattern recognition and kind of seeing context around the obvious and even making creative leaps. And, you can't go through any day these days without talking about artificial intelligence and what it's doing. So maybe talk a little bit about the dance of artificial intelligence and human intelligence, particularly in those things like pattern recognition and context and sensing those things that are creative.
Yeah, absolutely. So overall, my perspective on AI is optimistic, and I believe it's an extremely powerful tool that augments our own abilities. But at the same time, its rise makes our uniquely human skills and abilities more valuable than ever, I think, such as value-based judgment and contextual understanding, specifically like ambiguous goals, creativity, empathy, but also like pattern recognition, as we were talking about before. Yeah, for an example, previously I was working for an agricultural informatics company. And during my time there, I was working on an application that used radar to detect hail. And I think you could train AI to do a really good job of like trying to recognize the patterns there and have a pretty good result. But there was a uniquely human leap that was important, which was understanding the context of what does it mean for the farmer whose livelihood is on the line when these hailstorms happen? And so there's like this act of translating data into a human value, which I think is a critical capability that humans have.
That's very much back to the holistic thing, right? And seeing the big picture as well as the detail. What about the weak signals? that aren't always picked up by, kind of sweeping large patterns. And sometimes it's those things that are the
Mm,
contextual breakers. How do you recognize those?
right. Yeah. Yeah, that's a good question. And that does come back to these like uniquely human skills that are extremely valuable. Specifically, like the contextual understanding of these of ambiguous goals, like I had mentioned before, and that is something that we have noticed is a lot easier for humans to do than AI. Specifically, AI, we're seeing it's really great at automating repeatable tasks and things like that, but and pattern recognition as well. But yeah, it's taking the context into account that is really where we see humans' abilities really come to the forefront, I think.
Does that help in when you're designing things at Amazon and other places? Does seeing that context help you build for resiliency, or how does it help you build for resiliency?
Absolutely. And that's an extremely important part of designing systems in general, working back from the user or the customer, trying to think about it from their perspective. It's really easy in software development as a software developer to design something that you think is going to be great, but not take enough time to consider how the user is going to use it. And also to consider like the specific individual considerations that users have. It's really easy to discount that or even to not think about it. But it turns out that that is one of the most important pieces of software development. And you have to start with that and kind of work backwards a lot of the time to produce truly innovative software solutions.
How do you gather that understanding of the user and their real world?
Yeah, that's really hard. And it comes down a lot of times to customer engagement, reaching out and asking customers to fill out surveys and things like that, having focus group meetings. But it really comes down to just like investing a good amount of time at the beginning to gather all of this data, to gather as much data as you can and really focus on distilling it. It can be very tempting when you're starting a new project to just jump right in and start coding something. It's really exciting, and it's hard to fight that desire to just go. But as I've learned time and time again, the more time you put in up front to frame the right question and to uh, really take the time to understand your customers pays off in the long run in the form of a high quality software solution.
I couldn't agree more. One of the things we always do first in a third angle workshop is come up with the framing question. And sometimes that's the most difficult thing to do. What question are we really answering here without the answer already being assumed?
Yeah, exactly.
And do you deal with both quantitative and qualitative data?
Sure. Yeah, when you can, absolutely. You'd want to get qualitative and quantitative data.
So we've been applying this part of the conversation more towards building something new and creativity and innovation, which is fabulous. What about identification of root problems and problem solving? How do you use these same sort of techniques to identify root cause and not just surface issues?
Yeah, that's another extremely important question to ask. And knowing the difference is also extremely valuable. The difference between like the surface level fix and a root cause solution, when I think about it, an analogy could be like a surface level fix is like patching a pothole, right? But a root cause solution would be understanding the subsurface geology of the road and fixing the foundation of the road itself. So it's not just like slapping a band-aid on something. It's really truly understanding. I have an example of that when I was still in college. I was working at a medical device startup that I helped found. And the objective at first I thought was simply we just need to build this device for manual wheelchair chair users. But then taking a step back, we thought about what's the real problem? What's the root problem? And that was how do we prevent manual wheelchair users to have repetitive strain injuries? And so reframing that question and answering that question required me to go beyond just like writing code and creating the hardware, but collaborate with other people. I collaborated with like biomechanical experts and hardware engineers, doctors, other clinical scientists. And that also made me realize that some really important problems are commonly not confined to a single discipline, right? You have to like work cross boundaries to find meaningful and lastful solutions.
Do you have any secrets or tips to collaborating across boundaries and different ways of seeing the world?
What I've learned is just try not to be afraid to reach out. And sometimes it's easier to kind of like stay pigeonholed and just like work within your comfort zone. But yeah, getting outside of your comfort zone and reaching out, making connections, things like that is probably the best way I know to do it.
Well, from what I know of you, Adam, you're a terrific learner. So I'm sure you enter those relationships.
Yeah. So for me, I think there's going to be a few things that are important to kind of like master the interplay between like these powerful new technologies like AI, but also a deep understanding of systems. In my opinion, I think is extremely important. And then kind of going back to these like timeless human skills, I think the interplay between all three of those is extremely.
Mm, yeah,
AI is going to continue to evolve, right? And for software engineering, it elevates a software engineer's role from more of a just like a writer of code to an architect, right? Someone who's designing, guiding, directing complex systems. And as that happens, the ability to see the big picture, right? Like this systems thinking philosophy is more valuable than ever. But I think that also can transcend into business as well. And keeping in mind that these durable human skills of things like collaboration or clear communication, empathy, I think are also invaluable and are going to continue to be invaluable in the future, despite these exciting, rapid changes in technology, right? Because you're still going to need to build trust within a team, for example, clearly communicate a vision, solve real problems for real people, things like that. That's always going to be a constant and something you can't really like automate easily with AI.
right. For sure. Bringing those things together, once again, it can be used for problem solving and identifying root causes and doing new things. Do you have any examples of when you've been, entrepreneurial or creative or maybe took a project down a different track because of combining these areas of endurable human skills, systems thinking, and powerful technologies?
Yeah, so I think at Amazon, I've had a couple experiences where I'm leading a project or I'm working on a very large project that scaled beyond what I initially expected. Specifically, like the proof of concept stage. I've been on multiple projects where it just scaled way past that, where my position and my role tended to shift from more of just trying to architect this solution on my team or just my org to learning how to work across boundaries as we are talking about and obtaining alignment with other organizations in a way that we could scale this product up that is going to benefit everybody together and getting buy-in from everybody also is a really important thing. Yeah, that's one
Could I
example.
ask you another question about scaling that I know a lot of our clients always ask about? In their dream world, they can plan for and design for scale exactly what it's going to be, how it's going to play out. And back to the idea of complex systems, some of that is emergent once it gets going, hopefully in a good direction or not. How do you balance that sort of knowable planning, engineered scalability, and the let's adapt with emergence?
Yeah, I think it comes down to flexibility, having also built your system in a way that can easily scale up and down. Yeah, you can always expect and plan for a certain level of load on a system or a certain number of users using it, but you can never really predict exactly how everything is going to end up being used or being utilized. And so building for software, building something that can easily spin up like more servers or another network or something like that is key to enabling scalability in the long term. And that can be challenging, but that's another thing that at the design phase, even before you start implementing a project, needs to be fully considered and accounted for in your overall plan. And it also kind of comes back to planning for failure as well. You're not thinking like, how am I going to prevent every single issue from coming up when this starts scaling up? But maybe asking yourself like, how would the system behave when that does happen?
The upscaling up and down and adapting for failure of both the technical aspects, the human aspects, and the economic aspects. Has there been any time where something really surprised you, like that you thought the technical thing, for instance, was all figured out, and then boom, something happened economically or human wise that it's like that changes things entirely, and then you adapt?
Yeah, definitely. I can think of an example of that. At a previous company, I was working on software that was primarily used by farmers and other agricultural experts to plan out their daily logistics of what they were going to be doing in their field that day, but also for the rest of the week. And it was a simple website that we thought users would just kind of visit maybe once a day, not really much more than that. But we quickly realized after releasing it that users were using it in a completely unexpected way. Some tech savvy users were actually writing their own code that was hitting our website multiple times per second and running analytics on it on their own servers, which was completely unexpected, something we had never even dreamed was going to happen. But the implications of that were huge because incurred costs for us were enormous and way more than we ever experienced because of all this added usage. And also, once we realized what they were doing, which took a while for us to figure out, by the way, it was like not very clear exactly what was going on. After we realized that, we had to like quickly first like scramble to address the issue of being able to like scale this up for this use case, but also it helped us kind of realize that there might be a better way to address these specific users' needs in general and design something similar, but kind of tailored more towards their automated use cases.
They sort of led you down the path of innovation, right? Any advice or takeaways that you have for engineers and business leaders now in terms of preparing for these complex systems that are getting even more complex with data and
Yeah.
uses?
Yeah. I think trying to be adaptable is one big thing. We're just seeing the rate of change of these technologies increase, year over year. And it's amazing. And it's a little scary, honestly, to just to see how fast things are changing. But trying to be flexible, trying to be adaptable and maintaining that kind of point of view, I think is key to like keeping up with things, but also being open to new ideas that might unlock some technologies or some products that you might not have really thought about previously.
Just like the story you just told about the farmers, right?
Right.
Yeah. Well, Adam, it's always a joy visiting with you, and thanks for taking your time today to share that with us and our viewers, and we hope to have you back. It was great.
Great. Thank you, Gene.